All right, so we're going to go over an example of how you can apply the intermediate value theorem. So in this problem specifically, we're going to use the intermediate value theorem, or the IVT, to show that the function f of x is equal to 2x cubed minus 3 has a 0 in the closed interval 1, 2. So when you're going to apply and use the intermediate value theorem, you need to make sure that the two conditions are met. That is that f is going to be continuous on the closed interval, and that the f of a and f of b are not equal to each other. So their a is going to be, usually the first endpoint. So a is 1, b is 2. So you want to show that f of a is not equal to f of b. F of a is not equal to f of b. Before we can use it, you have to verify that this is true. So we find f of a by plugging a into the function. So you're going to get 2 times 1 cubed, so 2 minus 3. So f of a will be -1. And when you plug b into it, so when you plug 2 into the function, you'll get 2 times 2 cubed, so 2 times 8, so 16 minus 3, which is 13. And -1 is not equal to 13. So the first condition checks out. So we're good there. Now, the second condition you want to verify is that the function is continuous on the closed interval, 1, 2. So f is continuous on 1, 2. Now, usually your teacher professor will, give you, some defined functions and equations that are going to, be continuous for the values in their domain. And one of the types of functions that will be continuous are polynomials. And since this is a polynomial, we can then say f of f is continuous on the closed interval 1, 2, because it is a polynomial. Make sure you show that you check the two conditions before you go about any calculations in your problem, because that's how they're going to grade you on your AP exam. So show in some way that you're aware that those conditions have to be checked. Okay, now that we checked them, now we can apply it to actually complete this problem. So if we're going to use it to show that there's a 0 in this interval, that essentially means that this function can be equal to 0 for some x between 1 and 2. So the way I would write this is that we can set f of x equal to 0, meaning that 0 is going to be, 2x cubed minus 3. And we solve this for x. So we can get 3 equals 2x cubed, and then 3 halves equals x cubed. And then undoing the cube, we'll take the third root of 3 halves is equal to x. Now, you may not know it off the top of your head. I wouldn't expect you to, but that's all you have a calculator for. And so we take 3 halves raised to the 1/3 power, the same as taking the cube root. And we can see that x will be about 1.447. Or actually 1.1447. I think I said it differently. Yeah, and so 1.1447 is between 1 and 2. And so we're good. And we're done. That's all there is to it.